It's over with my ex, but we stay afloat cause you're my index. Seeing clearly now, don't need Windex. Zooming in once and forward and I don't need the context. I know less is more when you keep my data in check. Hey, I think you're the best for me. Hey, cause you help me see. Whoa, cause you're my index. Whoa, my data's in check. Whoa, cause you're my index. Index.
Fix that in a moment. Yes, I see. Okay, now it should be good. Very well. So I just greet you, and I have to do it again now because I have problems with my microphone, and now we should be live. So, hello, that's Aleksandr VOLOCHNEV and Cedric Lunden. We are from DataStax Developer Advocates team, and we are happy to greet you. That's an amazing day to learn something new. Hi, Cedric.
Hello, Alex. Happy to be there.
Yeah, that's a big pleasure.
Great content today.
Yeah, indeed. So, if you can see us, if you can hear us, please set the thumbs up in the YouTube chat so we will know what we can start. That's, I see. Pom, 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 pom. And great. So, okay, now it works, finally.
Okay.
Good. So, I see you can hear us, and that's great, because we are going to start. And that's what we are going to do today. So, Aleksandr VOLOCHNEV, Cedric Lunden, Developer Advocates at DataStax, Director of Developer Advocacy at DataStax, and today we speak about Cassandra data modeling methodology. Few things you need to know before we start. Live stream on YouTube and Twitch. If you attended our workshops already, you know how to do it. If you didn't, well, that's very easy. Our main primary stream on YouTube, but if you are having any problems with YouTube, if it doesn't work too well for you, we have a backup stream on Twitch to answer your questions. You can ask them directly in the YouTube chat, but that may be not the best way, because as soon as the YouTube stream is over, chat is gone, and we want to be able to discuss the things with you even after the workshop. So we recommend to use Discord for that. Easiest way to join our Discord server is bit.ly/Cassandra/Cassandra-workshop. And there are already very many people, like some thousands.
Almost 10,000.
Oh my God.
I think it's 9,800. And
So,
for the 10th thousand, let's bring some swag.
yeah, definitely. So we are going to have a lot of people today.
Let's celebrate.
Yeah, and even more in the next steps. Good. So, quiz. We love to ask questions, and we love to play a game and give you swag prizes if you win. So we use Menti. Menti is a great third-party tool, completely anonymous. You don't have to put your email address or credit card number or whatever. Just answer our questions first, and then later in the second part of the workshop, we play a quiz, a little game where the winners, the fastest people who give the correct answer, get the prizes. We are going to switch to Menti soon to ask you a couple of questions so we can set up the content for this workshop. And finally, to do the practical parts, to do the homework for this workshop, we will use Catacode.com. It's a great tool now by O'Reilly, publisher now. which helps you to do all the steps of learning without any need to install Cassandra on your own laptop or whatever you prefer. You just need the browser, and that's incredible. Speaking of the quiz, let us add some questions. If you did that already, you know what to do. Go to menti.com and use the code 34919972, or simply use this QR code, which is going to appear in a moment. Yep, and again, scan this QR code and you will be fine to go with Menti. So, how many people do we have?
Okay, on YouTube we do have about 40.
Okay.
And on Mentimeter, it's just me clicking the send up like crazy.
Yeah, I see people joining Menti already. 4, 5, 6, 7. Okay, I will show you the QR code again. So, I hope you have time to scan it. And we can start finally. Very well. So, what are my questions for you? Very easy. Yes, we definitely can start. How much SQL experience do you have? How much experience do you have with traditional relational databases? Okay. Great. Thank you for answering. It looks like most of the people we work today have some SQL experience, at least a lot, or some significant experience we definitely have here. Very well. That's, I mean, picture is pretty clear. Most of you have at least little bit experience or more. If you have no prior experience, it may be, this workshop may be a little bit harder for you, but you know what? Just keep going, you will get it in your time. So don't give up. Then, how much NoSQL experience do you have? I think picture will be different because most of the software engineers, developers usually have experience with relational databases, but NoSQL much less. And indeed, picture changes here. So much less people who use it on a regular basis. And
so I click the guru because, hey, next week I will run this workshop, Introduction to NoSQL, where I will talk about graph and GraphDB, document DB, key value DB, column oriented DB, and you can try all them. Shameless plug.
Yeah, but I mean, that's great. And actually, thank you so much for reminding me. Actually, we are doing workshops at least once a week. And it's really cool. Yeah, because next workshop we will speak about NoSQL in general. Today we speak about Cassandra, which is great of NoSQL databases, but not the only one. And there are other databases for other use cases, so that's great if you can join us next week. It's again free, and we will be happy to see you.
As usual.
Yeah, let's proceed. So I believe, yes, that picture is pretty clear. How much Cassandra or DataStax Enterprise experience do you have? So now, not only the whole NoSQL world, but in general. That's interesting. How much people we have with no prior experience. Okay, so biggest part has at least basic understanding, which is great. I see people have up to 1 year experience, 1 to 3 years experience or more, and that's great. So basically this workshop is for people who already have some understanding of Cassandra. We don't require a lot. But if you have no prior experience, we will run through the main features in the beginning, but it's a run through, so we don't stop on it for too long. We don't explain the basics, just only briefly to help you to catch up. In general, we speak about data modeling methodology and obviously it's a little bit different. So, but you can catch up. So there are no big worries about that. Good.
Alex,
Yeah.
we are 9,972 members on Discord now.
Okay. Okay.
Only 28 people to get that swag. That's funny.
That's
Anyway,
cool.
just move on.
Good. So let's move on. Okay, and last questions. What about normalization denormalisation? Does it sound to you? Do you have any idea what is it? Or do you use them regularly? Okay, I have basic understanding. I'm good on it. I don't know those. So don't worry if you don't know. Those are topics we have to cover, so we will cover them today. If you don't know those, you are at the good place. If you're good in it already, well, good to you, because those are important ideas. And then finally, how much your work is using databases. I mean, there are some developers like front-end developers, those don't work with databases usually. But then from the other side, there are people who work with databases all the time, like database reliability engineers, database administrators, database architects, data architects, and so on and so forth. So that's interesting to see how much people we have. I see some people getting error unable to accept invite.
Yeah, but I was able to do it, so let me try to create another one for people.
Okay, I mean,
needed.
we can handle it. We would be able to handle that in Discord chat after the workshop, but
Yeah.
people not able to join.
You know, this
Yeah.
is why we have two moving heads on screen.
Yeah, exactly.
You run and I can help. Let's
Good.
see if I can give
So
you.
I see. So most of you at least work with databases a lot, or all the time, or at least some time, which is great already. So thank you for answers. That's enough for us to set up the workshop. Don't close this tab, because quiz will happen exactly there in the second part of the workshop. Okay, so stay there. And now I'm to switch to the presentation, basically. Good. So, achievements unlocked. Some of you doing so great work attending the workshops, so we want to highlight you, your tendency to learn, your desire to acquire new skills. So we are introducing badges. Badges is to prove what your upgrade complete in the field. Like for today, it's Cassandra data modeling methodology. So, for example, you see some people got that already for Cassandra workshop and for Intro to Cassandra workshop. And I want your names to be here and, of course, on our LinkedIn posts in the future. So don't forget to do the homework.
And it's just the beginning. For now, it's just a couple of badges, but you know, we will do some gamification and start to send some swag after a couple of badges and points. It's coming in the coming weeks.
Yeah, so it's just very new. You are in the beginning of this shiny new thing. Now, what is the homework? I will give you the links in the end, but you will have to do 2 kata scenarios. Again, knowledge is priceless, so those are free. And you don't need anything except of your browser. You will get the links in the end. Specifically, we will speak about Cassandra data modeling scenario and sensor data modeling scenario. And we are ready to start with Cassandra data modeling methodology workshop, or I prefer to call it how not to screw up with Cassandra. Because, well, we don't need data modeling per se. We need actually to build efficient data models, to have our applications and our system running efficiently and our customers be happy and so on and so forth. So that's why it's about how not to screw up with Cassandra. And not to screw up, you need to know only 2 things. Know when to use it and know how to use it. And both are very important. If you don't know when to use it, then you may pick an improper tool. And then it will be like sometimes you are using database which is not fit your use case, and then you look like this guy, which is obviously using the wrong tool. But sometimes vice versa, people are taking Cassandra for the project where they really would need SQLite or something like that. And that's also very wrong. So that's very important to understand when to use it. But second, which is also very important, is know how to use it. Otherwise, you can be like this guy, like doing things in a little bit not correct order. Okay, so that's the main things for our workshop. When to use it and how to use it. So, what Cassandra is good for? And following point, what is bad for? Let's take a look. So, very beginning, Cassandra is distributed, decentralized, NoSQL, no relational database. You can have your Cassandra running with a single node, but that mostly doesn't make any sense. Cassandra is distributed database, so usually you are going to have multiple nodes to spread your data over them. Usually we start from at least 3 or more. Some companies, like big companies, tend to have hundreds and thousands and dozens of thousands of servers. Depends on how much data they have. Every node communicates with every node. There are no masters or slaves or write replicas, read replicas, things like that. Nothing like that. Nodes together build data center or a ring to work together and communicate together. Cassandra scales linearly, and it's one of the killer features of the databases. A lot of other databases don't scale at all or scale very, very, very badly. So you have one node, you add a second node. Your performance will not be twice higher. You have 2 nodes, you add 2 more nodes. Your performance will not be 2 times higher, and so on and so forth. There is always some limits on the scaling, and there is always some problems with scaling. With Cassandra it's different because Cassandra scales elastically and linearly. You need more firepower, you add more nodes, you have it, and again there is no overhead on adding new nodes. You need more capacity, more disk space, add more nodes, and you will be fine. Data in Cassandra is distributed. So you see on the right this table with country, city, population, basically how many citizens you have per city, per country. And data is distributed. What does that mean? It means what this table is not copied to every node, not copied to every server of your cluster, but spread it on your cluster instead of that. Why? Answer is very simple. Databases, traditional relational databases you use all the time, they tend to have all the data on a single node. It works as long as your data fits on a single node. And then at some point you're getting too much data and your data doesn't fit to a single machine anymore. Vertical scaling has some limits and you run into troubles like with sharding. You have to distribute your data over multiple servers, and sharding with relational databases is very, very, very painful. I did it a couple of times and I can tell you avoid it at all costs. So...
No, indeed.
Yeah, Cassandra works differently. Cassandra is big data ready. Cassandra is ready to handle your data, and it distributes data over multiple servers in order to be able to handle any amounts of data. If at some point you are getting too much for your cluster, what to do? Add more nodes. Very simple. Data is not only distributed, data is also replicated. So your data stored multiple times over your servers of yours. What you see on the left is replication factor 3. It's a recommended number for most of the use cases where you have replication factor 3. Every record, every row, or better to say every partition is stored on 3 different servers. It means what you can afford losing a node and still be able to get the response. So if one of your servers is on fire, on power outage or network outage or whatever, aliens destroyed your server, it doesn't matter as long as you have its other 2 replica servers running, you can get your data loaded or inserted, updated. And as soon as failed node recovers, it will receive notification of happened operation while it was not available from other nodes, from its neighbors. This mechanism is called hinted handoff, and that's absolutely automated mechanism. You don't have to do anything for that. Cassandra is self-healing, and that's great. So it helps a lot to operations and database administrators because it's self-healing. Basically, you can lost one node over time, recover by the morning, and in the morning you will know about that only if you are watching monitoring, because your database was available all the time despite the server was down, and that's kind of cool. Then next point for us is this data distribution, geographic distribution and cloud distribution, and provider agnostic. You can have multiple data centers for Cassandra cluster working together in different regions, and they all are active. So that's an active data replication from all over the world. You know Netflix? Do you watch Netflix? You use Cassandra all the time. Do you use Apple? You use Cassandra all the time. Globally distributed companies are in deep need of Cassandra because Cassandra allows native cross-continent data replication, again fully automated. There is nothing for you too much to set up, well, except if maybe you want to do some network operations to make like data replication quick, of course. But again, you may have multiple data centers, and what's again is great with Cassandra, you can specify how many of the data replicas you can have, you will have in the data center. So you can say what for this key space, for these tables, I want to have 5 replicas of my data in the United States data center, 3 replicas in European data center, and 0 replicas in China, because this part of my application is not used in Asia, so I don't need to have replicas there, for example. It perfectly works. Another point is vendor agnostic. You can run Cassandra everywhere, and it can be Microsoft Azure, Amazon Web Services, Google Cloud Platform, or your own data center, whatever you prefer. And they again are parts of the same cluster, so they can work together despite you run them on the different cloud providers. In hybrid cloud, multi-cloud, whatever cloud, it still works together. And that's again a very powerful feature. Very important thing to understand, which is very often forgotten, OLTP, OLAP. What does that matter? Let's say there is a line. On one side we have OLTP databases, on another side we have OLAP databases. What does that matter? You use OLTP databases when you need a very high performance and you need answers now, right now. You don't want to wait. This site usually works with your clients, like you don't want to make your clients wait. They will go to your competitor if you make to wait them for too long. For OLTP applications, it's more typical. For OLTP databases, it's more typical to have simpler queries, not always simple, but simpler, let's say. And queries don't change often. Yes, of course, every business develops, every system develops, so your queries you run day over day, day by day, tend to change in general. Of course, like business requirements are changing, it's normal, but they don't tend to change every minute. Mostly probably the queries you are running today, you are going to run tomorrow on your system. And on the other side, we have OLAP, Online Analytical Processing Databases, which is a different field. Answers can wait. Our analytics work on the data of our clients to build better offers, for example, and they are my colleagues, they are employees, they are getting paid for their job, so they can wait. But what they do are very complex queries. They need to have a very full understanding on what's going on in the system, and they always run complex queries, and their queries tend to change all the time. Today we need to understand some of the users' behavior. Tomorrow we have to understand of some users' behavior related to our next actions on the market, and that's all changes day by day. Today I focus on one thing, tomorrow I focus on another thing, and queries are different every next hour, let's say. So we use it to use traditional relational databases, and they are somehow in between, and you can have both. You know, like jack of all trades, master of none. You can use them as OLTP databases, not perfect, but it works. You can use them as OLAP databases, not perfect, but it works. And then Cassandra is much more on the left side of the things. It means it's very performant. You get your answers now. It means what with simple queries, don't changing too often, you will feel comfortable with this database. But if your queries change daily, if you can wait, and if you tend to use very complex queries, if your query consists of dozens of joins all the time, then, well, we will see how to handle with denormalization. But queries tend to change. That's definitely a sign you need something more on the online analytical processing than online transaction processing. And that's pretty important to understand. But now you may ask, okay, most of the companies, especially big companies, tend to need to have both. I mean, yes, of course, like your Instagram is one of the big developers of Cassandra and big users of Cassandra. They need answers now. They have very strict requirements for the response time. So, okay, but they also need some analytics on data, what they have. How does it work? In short answer, teamwork make great work. For analytics, you may need tools like, for example, Apache Spark. Apache Spark is perfectly integrated with Cassandra. So you can have both of OLTP and OLAP. The point is you can have platforms like Teamworks of multiple products working together to have both, but you cannot have one single database good in all of these positions. Usually databases tend to be more in the center or to the left or to the right of this list. So what it makes Cassandra good for? Cassandra is big data ready. If you're going to have a lot of data, Cassandra is maybe a great fit for you. Cassandra delivers highest availability, and that's great. Cassandra brings geographical distribution, and you work in the truly international company with geographical distribution for your strict requirements on response time may be great. Keep your data close to your clients. Then, read-write performance. Cassandra is highly performant. And finally, Cassandra is vendor independent. You don't get into any kind of vendor lock. You can run it everywhere where you want it to be running. Now some downsides. Cassandra requires qualified engineer. Cassandra is not a simple thing to run. Cassandra is pretty demanding. And Cassandra is OLTP specific, as we discussed. Regarding qualified engineers, there are 2 points. If you need to build Cassandra database and you don't have qualified engineers, then maybe you can think about DataStax Astra. DataStax Astra is a Cassandra as a service. It's managed Cassandra, and you already have those engineers, DataStax employees, taking care of your cluster. So that may be a good solution if you cannot hire qualified engineers right now. But where is the second outcome? As most of you, I believe, tend to be engineers, when there is a simple thing. Cassandra is in high demand on the biggest companies on the planet. So if you want to get raise, if you want to get better salary, then Cassandra is a very good skill to learn. That we definitely can prove. So yes. So yes, Cassandra requires qualified engineer, which is bad for you if you are a CTO, for example, but if you are an engineer, it's really good for you. Learn Cassandra, get better salary, very simple. So when we get to the last slide of this part, use cases. Everything what relates to highest scalability and performance, highest availability, distributed workloads, and cloud native. It relates to all the aspects of the Cassandra. You are going to have heavy reads, heavy writes. It's fine, you can get it with Cassandra. unlimited elastic linear scaling, you are good to go with Cassandra. Mission critical data, no data loss, always available, Cassandra. Distributed over the world, or limitations like GDPR when you have to specify where exactly you store your data. Perfectly fine, you can do it. And cloud native application, Cassandra runs natively on Kubernetes. We have a dedicated workshop on that, and so on and so forth. You want to have multi-cloud or hybrid cloud, Cassandra is a perfect match. Cassandra is cloud agnostic and platform agnostic. And are there any good questions to answer, Cedric?
No. People are very calm this morning. They are listening to you, I guess. Nice presentation about OLTP versus OLAP. So OLTP all about online transaction processing, real time. When it comes to OLAP, it's analytic processing. So it's batch query, some stuff you used to do with big data or data warehouse, that long running query for n+1, not the day or what you need to be super fast.
Yes, exactly. So yeah, thank you indeed. I believe people use it to use general purpose databases all the time. We all use it to have general purpose databases, which can be both a little bit of OLTP, a little bit OLAP, not perfect in both of them, but able to deliver difference. There is a question, what's the difference between hybrid and multi-cloud?
Yeah, you read that.
Yeah, multi-cloud means what you use multiple cloud providers. For example, part of your application runs on Google Cloud Platform and part of your application runs on Amazon Web Services. And you work them together. Let's call it multi-cloud. And hybrid cloud means when you use a public cloud provider like AWS, GCP, Azure, but you also use your own on-premises data center, your own data center. It's not easy, but sometimes it's required. For example, if you want to have 100% uptime, you cannot afford using only one cloud. From another point of view, 100% uptime with Cassandra, it's reachable, but, well, pretty expensive. I mean, you need to have all the cross data center, cross cloud data replication, which is not cheap with AWS, for example, quick, but not cheap, and so on and so forth. Good. So.
Yeah, so a question on transaction. We are stating OLTP, and T is for transaction processing. So transaction really mean action or operation or services, not really ACID transaction. It's just an operation. When it comes to transaction with Cassandra, because we had the question, there is no ACID transaction because Cassandra make the choice to be available and partition tolerance and less consistent among the node. No ACID transaction yet. So a transaction is really what we call a mutation, read and write.
Yep, exactly. Giri Prasad, very good question. Exactly as Cedric said, in OLTP, T stands for transaction, S for operation. Insert, read, select, update, delete, things like that. So it's not in the point of commit, rollback, and things like that.
Exactly.
Good. So then we go to relational and normalization, NoSQL and denormalization. And that's a big topic. Like most of us got normalization, idea of a normalization, I don't know, in the university or learning databases on our own. And normalization is great, but there is a problem with normalization. People use it to consider normalization as the holy grail of data modeling. And with all the normal forms, with a normalization, at some point it starts to be like, a holy symbol. You need to have normalization, you need to have your data normalized. And not being a devil's advocate here, but I want to say what actually world is a little bit wider than the just limited approach of a normalization. And you can have more tools. And force has two sides, and there is a dark side of the force. Call it denormalization. And we aren't in a Star Wars movie, so you can have light side of the force and a dark side of the force simultaneously, and it's perfectly fine. Actually, it makes you much stronger, so you can have both of them and use both of them. Okay, so what's the normalization? Normalization is a process of structuring your data in your database the way so you reduce data redundancy and improve data integrity. First is proposed by Edgar Code as a part of his relational model. Basically, the idea of a normalization is to remove any data redundancy and store every piece of data only once without duplicating that. So, for example, here we have list of employees and we have list of departments. And we have departments stored in the department list, and we have employees working in this department connected via relations, connected via foreign keys together. So, what it means? It means simple updates. If I want to rename my department, I need to execute one simple update statement, one write. But it comes with a costs. If I want to read data and I want to show information about my employee, not only name, but also a department, I need to execute a join. And join means I have to basically select from two tables. And well, joins are great, joins are powerful, but they have one downside: they don't scale. They may work on your single host database. They may work on some limited amounts of data. But when you have petabytes of data spread over hundreds of servers, they don't scale well enough, and you will wait for answer for minutes if a case of any problems. And Cassandra is designed to be very quick under any circumstances. So, benefits of normalization: simple writes, data integrity checks via relations, foreign keys. The downsides: slow reads, complex queries. And indeed, queries are complex. If you have ever tried to maintain a query of a dozen or 2 dozens or 3 dozens of joins, you know how much fun is in it. Sample relational database goes very simple way. You create entity table, you add constraints, you add your index fields, you add foreign key relations. For example, we have table users, we have table videos, and videos will have they may have some constraints. What user ID? It may have some reference on delete cascade. If user is being deleted, automatically delete all of his videos, and so on and so forth. So basically, you have relations between tables. Cassandra query language SQL works differently because it's a NoSQL database, no relational database. There are no joins and highly limited aggregations. For the same reason, joins don't scale and aggregations also don't scale too well over data. So there are some limited set of aggregations you use to have on the relational databases. What it brings to us in the end? And the relational data modeling. How do you use to do that? You have raw data, you analyze it, you identify entities, their properties and relations. Based on that, you design tables using normalization, removing duplication. And you use join when doing queries to join normalized data from multiple tables to get your answers. And then you apply denormalization when you need a higher read performance. So it happens with relational databases, you want to use denormalization. Okay, but what's the denormalization? Denormalization is another side of the coin, another weapon you may need to use. Denormalization is a strategy used to increase performance. In computing, denormalization is a process of trying to improve the read performance of a database at the expense of losing some write performance by adding redundant copies of the data. So take a look. Now we can have table employees with Edgar Code Engineering, Raymond Boyce Math, Sage Lahya Math, and so on and so forth. So we are duplicating data. Now, if we want to rename a department, we will need to change it in multiple places. We still need list of the departments, and data is in the employees list. But you know what? Normalization, like the fifth normal form, they are too aggressive. They have perfect one single write, but then multiple reads, because join is basically a multiple read, and that's said that's don't scale, and we want to have read fast, not also write fast, but read fast. But you know what? There is a funny point. With denormalization, when I do writes, I very often have to do multiple writes. I need to write to multiple tables. I'm renaming my department. I have to update now a departments list and employees list to update everyone who works in the department, engineering department, for example. But what's the point? These writes I can execute simultaneously, asynchronously. So despite there are 5 writes, let's say, they're still being executed on exactly the same moment of time. But when I'm doing select with joins, I cannot do it simultaneously because there is a join on join on join on join. They are blocking, they are synchronous. There is a big fat problem. It is blocking while a multiple writes simultaneously is asynchronous and non-blocking. That's why it still works much faster, and it works fast enough for writing as well. So with denormalization, our downsides, now we have to do multiple writes, and we have to manually maintain integrity. So it's not data integrity is not anymore responsibility of the database, but responsibility of the application, and therefore application developers. But you know what? I don't mind as long as I'm getting paid for that. That's a part of the job. When from the other side, benefits of denormalization: quick read and simple queries. Queries are easier to maintain, no joins, queries are short, they are easy to read and easy to adjust. And then quick read, you don't now have to do select from join. You just completely enough to do one single select. And that's actually really cool. Denormalization has its own downsides, and denormalization has a lot of problems, for sure. I know it really well. But we use it, but we have been told what normalization is great and denormalization is awful. And I do not agree with that. They both are tools to be used in the proper time. It's not bad, the denormalization per se. It's wrong when you are using denormalization unwillingly, just because you don't understand those concepts and you duplicate data, not because you require highest performance, but just because you don't know how to do normalization. That's what's wrong. But in general, you need to understand both of them and know when to use them all. Okay. So, Cedric, any interesting questions to answer?
We had some question relating what's the difference with others NoSQL database like Mongo, and so I start answering. But again, next week it will be really about what is a document-oriented DB, what is a column-oriented DB like Cassandra, and what are the use case of each of those. So yeah, yep. I did the job answering already, I guess. But
no doubts.
Keep the question coming. I'm here for that.
Yep, great. And yeah, that's actually a funny point. We use it to think what there are SQL databases and NoSQL databases, and they are more or less the same by size. I mean, size like the amount of databases, amount purposes, and so on. But actually, when you start to think about that, when you don't use general purpose databases like these OLAP OLTP general purpose database somewhere in between of this line, we start to use purpose built databases. How do you think how many database offers Amazon Web Services, for example? Cedric, how do you think? Well, you know the answer more or less, maybe not specific number. How many databases engines are offered by Amazon Web Services?
How many? With the serverless, the flavors, I don't know, about 15?
Yeah, around 15. If we go deeper, it will be even higher, but in general, around 15 database engines. That's because we prefer not general purpose databases, but purpose-built databases. Databases specialized for some purpose they did well, but maybe not so good in all the others. So yeah, there are a lot of NoSQL databases, and you need to understand their purposes to stay efficient with the databases. There is a question again from Giri Prasad. So Cassandra prioritizes read over write by adopting denormalization. Well, yes and no. So you see, Cassandra is just has quick reads and quick writes. And whatever you prefer depends on your data model. Basically, you cannot have too normalized data model, otherwise you will have to do somehow application joins, which is definitely going to be painful. So with Cassandra data model, you definitely tend to use denormalization because you can execute writes in parallel and you cannot execute joins in parallel. Well, there are no joins in Cassandra, but still things like that. But I wouldn't say it prioritizes read over write like that. I mean, that doesn't sound correct to me, sorry.
So in a way, writes are a bit cheaper than read in the Cassandra world because you write only in memory. And you need to understand that we want to write the data multiple times in multiple table if you do have multiple queries, because you really want to store the data in the way you want to retrieve that. But we will go deeper in that in a moment.
Yep.
But in a way, duplicated data in Cassandra is not a big deal. It's what you want to do.
Yep. Cool. So, applying denormalization, we combine table columns into a single entity. We eliminate need for joins, but having data together for all the fields you have to retrieve, you have them in a single table and you retrieve them together, so no need to use joins. We don't have joins. And queries are simple and easy to understand. So in this case, again, the same example, we have all the data stored together, and join and select statement is simple and doesn't include any multiple tables. Denormalization in Apache Cassandra is critical. And you really have to think of your queries first. So then you think of your query. Query is the queen, query is everything. When you have query, you may think of designing a table good for that. And how do you do that? We explain in the next part of the workshop. So once again, in relational database, one query can access and join multiple tables. In Apache Cassandra, you cannot join data because joins don't scale, and queries can access on the data from one single table, one query per table, and sometimes one table per query. So, modeling queries, we have to think, what are your application workflows? Knowing your queries in advance is critical, and it's different from relational databases because I can't just join or create a new index to support new queries. Well, that's not perfectly correct. You can create indexes, but they run into the same problem, distributed system. Distributed indexes are pretty expensive and not so efficient than like single host database indexes. And it can go to up to one table per query indeed. So take a look. We work a lot. We will discuss today a lot a killer video. And what is a killer video? Killer video is a YouTube-like application, demo application we use to show how we work with Apache Cassandra and DataStax Enterprise. So what you have to understand working with designing tables for your own application are user customer workflows, how exactly people using your site. So here I speak killer video. It's exactly the same for YouTube. So YouTube, I will say YouTube instead of killer video just to simplify a thing. A typical workflow for the video hosting site like YouTube. User logs into a site. Mostly probably we will need to show basic information about user. We may need to show videos added by this user, and maybe show comments posted by this user, so he or she will see all the ratings, likes, dislikes, answers, and so on. And disregarding if it's user logged in or not logged in, we need to show latest videos added to the site, most popular videos, search video for by tag, and then video is selected. We need to show video and its details. We need to show comments for a video, like you open video page, you see the video, ratings, comments, and well, yes, show ratings for this video. So typical application workflows. Why I'm speaking about workflows again? Because your queries are based on the workflows. Like there is a reasonable sequence. User logs in, we show user profile. Therefore, first we will need to execute a comparison of the password. We will need to retrieve user credentials from database, and then we will need to retrieve user profile information from the database. That brings us to two select statements, you see? So, leading to queries for different workflows, we will have user logs into a site. We will need to find user by email address to check the password. User opens a video. We will need to show comments for a video, and we have to find comments by video, latest first, and so on and so forth. So this idea of workflows converting into queries, that's important to understand. We start with a workflow. NoSQL data modeling goes in the following way. We analyze your user behavior, you analyze your customer workflows. How exactly are they going to use your application? What's the purpose of your application? And you identify workflows, their dependencies and needs. You define queries to fulfill those workflows. And knowing the queries, you design tables using denormalization. And then you use batch, then inserting or updating denormalized data of multiple tables. So as you see, in NoSQL data modeling goes exactly opposite way. Not data to model to application using those models, but vice versa, application to models to data, applying models to structured data in the way how you need that. And then finally, we are ready to proceed to the next part with the data modeling methodology. So, any questions so far? Any good questions we have to answer by voice?
No, I'm looking for more documentation, text documentation for data modeling methodology. And just a question, what is the max number of table we can create in a DB? I don't think there is really a maximum number of table. When it comes to operation, if you go above, let's say 500 per key space, you can get some slowness, but if you can build multiple key spaces. So I don't think there is a limit as long as you split your tables efficiently in multiple key spaces.
Yes.
But Fred, I'm looking for documentation for you, on your two questions.
I believe there were some discussions on that on the TLP blog. The last pickle, great Cassandra experts. We are very happy to have them now as a part of the DataStax, as DataStax acquired TLP. And that's actually a really, really great upgrade for us, because those guys, like one of the best experts in Cassandra in the world, with no doubt.
Okay, found the link, sharing the last pickle link there.
So again, Giri Prasad, you asking very good questions, but this time you run in front of the train. Step aside and wait for a moment. We are getting to it exactly right now. So you will see. Cassandra data modeling. And we are very close. So just last few phrases about the data structure, and we start with the process. It all starts with a cell, intersection of a row and a column which stores data. Goes through the row, which is a single structured data item, a set of cells spread by columns. And then finally we have a partition. Partition is a very big and important thing. When you design your model, you have to think of the partitions at all times. Why? Partition is a thing that's stored together. Do you remember why do we do partitioning? Because we may have too much data for a single server. But even when you have partitioning already applied, you still can have too much data for a single server, even if you have some partitions. You need to understand the partition. Partition is a base unit of access in Cassandra, and you have to understand what is it and how it works. So then table consists of columns and rows storing partitions. And key space is a key space which contains multiple tables. So overall we have key space, tables, partitions, and rows within the partition. And basically every table consists of rows, data columns storing data, clustering columns making primary keys and sorting order, and partition key columns making the partitions. So when I create a table in SQL, I have to specify a few things. I have to specify create table. Key space I'm going to use. Table I'm going to create. I need to create some column definitions. City, last name, first name, address, email. They all type text. Don't worry, we have more data types than only text, for sure. And then primary key. In many relational databases, you use it to throw inserts to your database and get the ID of the data you store from the database. It works with a single host databases again, but Cassandra is distributed. Then to return to you an identifier from a database, they would need to agree on this number for all of the replica nodes, and there may be many of them if you use high replication factors. So obviously that would be not the best choice. So we design primary keys on our side, and universally unique ID and ID for an entity has to be generated on the application side. Usually recommended to use UUID, universally unique identifier. So in this case, partition key will be city. It means what our users will be partitioned by city. And last name and first name are clustering columns, and email is also clustering column. Primary key is an identifier for a row. It consists of at least one partition key or 0 and 0 or more clustering column. Must ensure uniqueness, may define sorting thanks to clustering column. So primary key main duty is to define uniqueness. Take a look. My table here, users by city, has city, last name, first name, email. And that's example which works. What would be wrong with this bad example? City, last name, first name. What's wrong with this primary key downside? Could you please answer on the YouTube chat so I see you understand what I mean with a bad example? Cedric, don't give them hints.
Yeah, it's like to ask questions like that. Make them work a little bit.
Yeah. Yeah.
Why this is a bad sample? Okay. Why just, city as a partition key only could have some flaws.
Yep. City, last name, first name. What's wrong with this primary key? Actually, there are two problems. And I want you to discover both, and I will help you. It's not unique. Might not be unique. Perfect. Anil Kumar was the first one, and Ogayu Okechukwu.
Yeah, it's not easy.
Yeah, and more people are answering. Yeah, and Fred discovered the second issue. Exactly. I see Lindsay Holman also confirms that. So indeed, this example, first of all, first problem it has, it's not unique. Can you imagine how many John Smiths we have in New York? I've checked like more than a dozen. Every next John Smith will lead to absurd and will overwrite data of the previous John Smith in our database. And that's obviously not a good idea. That's why first example uses email, exactly, to have to confirm the uniqueness, to bring the uniqueness. But there is a second problem, as Fred says. In this case, we have city only as a partition key. And okay, we have some cities like my town Otterberg. I am currently living, and it's around 3,000 citizens, so not so much. But there are cities like, I don't know, New York, Mumbai, Delhi, and so on. There you have much more people. And as a result, some of your partitions will be too big, too hot, and some of your partitions will be too small, which makes data distribution uneven. And we want to have even data distribution. Yeah, Giri Prasad asks for explaining clustering column. Again, I didn't explain clustering columns yet. We are getting to it to the next slide, don't worry. So, partition key. Partition key has very, very important duty. Partition key is identifier for a partition. It partitions rows, and all the rows with the same partition key will be stored together as neighbors on the same server. So, as discussed, partition key, it's important it to be of a reasonable size. For example, here we talk about video and comments for this video. And we use video ID as a partition for the comments. It's a pretty good example. It will work because, well, store together what you retrieve together. I open the video, I want to see comments to this video, and I want this query to retrieve comments to be simple. So I store my comments for a single video together. I retrieve them with a single network operation, not asking dozens of servers, but asking one server. That's efficient. And I retrieve together what I stored together. Very good. I'm going to have, in this example, have as much much rows within my partition, as much comments I have for a video. Second example, primary key user ID for a list of users. In this case, I will have as much partitions as rows I have, because user ID is unique by itself. Therefore, every new user will create a new partition, and it's perfectly fine. You can have nearly any amount of partitions. So it's perfectly fine to have one row per partition, as long as it suits you well. And there is a bad example, for example, with sensor ID and logit add, but I will explain this bad example later on a special slide, why is it bad. And clustering column. Clustering column, we are getting to that, you see. We have this table, users by city. Again, city, last name, first name, email. And what's the clustering column's purpose? So those three, last name, first name, email, are clustering columns. What are their purpose? They are used to ensure uniqueness as a part of a primary keys, and may be used for sorting order if you need sorting order. So we discussed it already. City is a partition key, last name clustering column, first name clustering column, and email. We add email to ensure uniqueness. That's clear, that's what we discussed. But there is a second example of video comments. Video ID is a partition key, comment ID as a clustering column, but also created at. We do not need created at as a clustering column to ensure uniqueness, because comment ID is unique enough. There is no need for more steps. But we want to be able to sort comments by creation time to show most recent first. And I introduce here created at just to have them sorted by design. That's why I use this created at as a clustering column. Technically, those are used together as a single data type, call it time UUID, but we will see it in the next steps. So, now, the most important slides of this part of the presentation before we start with modeling. Rules of a good partition. Now please focus, and if you have no time and going to quit, stay with me for some more minutes, because this is really important. Rules of a good partition. If you follow them, your application will be fine. If you don't know them, if you don't follow them, your application will run into troubles. First, store together what you retrieve together. For example, as said, we tend to show comments all together for a single video with a single network operation, not in a dozen of them. So I store my comments together within a single partition and I retrieve them together, and that's very convenient. You obviously can imagine thousands of use cases like that. Whatever kind of a data you work with, you want to retrieve together all the time. For example, order management, you develop an e-commerce application, there is a lot of them, and people are doing orders, and you open order, you want to see all the history of its order, like it was created, it was confirmed, it was paid, it was shipped, it was delivered, it was cancelled, and so on. All the order history, every piece of order history is a record. You store them with a single partition by order ID, and you retrieve them together in a single select statement. That's clear. Second point, avoid big partitions. So we discussed like video created at comment ID. You may say, hey Alex, there are some videos on YouTube, those have millions of comments. Really? And yes, my answer is indeed yes, but what is a video, what is a comment for a video? It has video ID, comment ID, author ID, author name, because we are using the denormalization, and comment text. So basically 5 fields, maybe a little bit more, timestamp, okay, but they all are text fields and mostly short. So there can be a lot of records, but they will be very lightweight. And what are the limits for size? There is only one hard limit, up to 2 billion cells per partition. So columns multiplied by rows, up to 2 billion cells per partition. There is a hard limit. But there are also 2 recommendations. Don't go over than 100,000 rows per partition, and don't go up to 100 megabytes per partition. You can go higher, those not a hard limits, but we in general recommend to avoid that to keep your database at maximum performance. So must be like that. And this example, as you could guess, when we partition our users by country, you know it's the same problem as with cities, but worse. You have countries like Monaco or Vatican.
Very small.
Yeah, there's some hundreds or maximum thousands of people. And you have India, China, and so on. The count is very different. That will lead to uneven data distribution, and that makes problem. But you know what? I told you to avoid big partitions, and most of the people understand that, as long as you know how partitioning works. It's something you can understand, but there is a mistake people are doing all the time. Avoid constantly growing partitions, because they will be bad over time. That's a real life example. Example happened with one of our clients. I will call no names, so you know, clients are clients, but it's a real life story. Imagine you work at a huge telecommunication company, and it's a global transnational telecommunication company having data centers, dozens data centers all over the world. And of course, there is a lot of infrastructure to monitor, and you have really millions of sensors all over the world reporting their state regularly, very often. And every sensor reports its own ID, timestamp, when it was registered, and some value. Which value? It can be different depending on the sensor. So it can be temperature, humidity, network throughput, whatever other things you would measure regarding the state of your infrastructure, and they report it every 10 seconds. And imagine you created a table like that. Primary key of sensor ID and reported at, where sensor ID is partition key, reported at is a clustering column, and basically it answers all the calls. You have sensor ID as a partition, you store together what you retrieve together, and you have reported at to have sorting by time, and well, value is just a data column. And this approach works in the beginning, but then you run into trouble. And I kindly ask you to tell me in the YouTube chat what will happen and when it will happen. There are two answers required actually. And what will happen is very tightly connected to when it will happen. And I see there is a question by Anil Kumar. It's always tough to handle 100 megabyte size rule and ever-growing partition. Any idea how to maintain balance? We discuss it exactly right now, as soon as I get first answers.
Yes, looking for your answer, but I see also some question from Adrien. How can I get statistics for each partitions? So you need to use the command line and the tool called node tool. And for this one, you will do a node tool table histogram. And then you will see where are those big and hot partitions. So node tool is the way to go. You can also go to help of node tool and see that you will have more info, not only on partition, but also on tables or SS tables, the underlying physical files.
And we have the right answer, basically. So first answers were not right. Too many partitions. It's fine to have many partitions. It's absolutely fine to have many partitions. Multiple sensor ID created, so more number of partitions at the same time. That's perfectly fine. But what's the problem is ever-growing partition. So yes, Anil Kumar is correct. Very good answer, Anil. Two big partitions, indeed. They will be fine in the beginning, but after a few months of writing data every 10 seconds, you will run into trouble. Your partitions will be too big. And there is no way, as Wojciech Pierre Vola says, there is no way to divide the data into separate non-granular partitions. So how do we solve that? With bucketing. So technically there are two ways of solving this problem. First way, call it TTL, time to live. In Cassandra, then you insert data, you can specify time to live for this record or even for the column value of the record. That's cool. And then, for example, you can say insert sensor report, sensor ID, timestamp value with time to live 3 months, for example. And it will be automatically cleaned after 3 months. And boom, your partitions are always contained clean, and all dates are, old records are automatically deleted. Again, you don't have to take care of that. That's incredible. But it wasn't our case in this particular example, because they wanted to store the data for longer periods. And when we have to introduce bucketing, take a look what bucketing means. Now we use a composite partition key consisting of two parts, sensor ID as before, but also month year. What is a month year? Month year is an integer or string, it doesn't matter in this case, which consists of month and year. Now, for example, that's a merge of year 2021, therefore my month year will be 032021, and next month year will be 042021, so April of year 2021. What is it good for? The point is, you start a new partition every new month, and as soon as you put as soon as month is over, partition is kind of closed, and you don't write to this partition anymore. You create a new partition instead of that. As a result, you always have nice sized partitions. Those aren't too big, and it works perfectly fine for most of the use cases. Now, some people usually ask me, why wouldn't you use date to make partitioning with date, which is a normal date like 1st of April 2021, instead of this month year? Why wouldn't you use timestamp? And the answer is, there is a very important point to understand. You want to avoid full cluster scan at all costs. What does that mean? When you run a query against some data, you must always specify full partition key. And therefore, if I have sensor ID and month, and I'm going to retrieve data for a sensor for the year 2021, my query will look like select blah 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 fields from sensor information table, where sensor ID equals 1 to 3, and month year is January or February or March. Pretty simple statement. But if I'm using date instead of month, when it will be retrieve the data, select all from sensors, sensor reports where sensor ID is 1 to 3, and it's 1st January or 2nd January or 3rd January or 4th January or 5th January, and so on. Can you imagine this query for half a year? That's not going to be maintainable and simple. So that's why we tend to use month year in this case, and it works very well. And that's why date may be not so good approach. Of course, it depends on your use case. So avoid big and constantly growing partitions. There is a question, how does bucketing affect data distribution across nodes? So take a look, very easy. Bucketing help us to create more partitions of a smaller size. Partitions are distributed over the cluster. So it basically helps to spread data over the cluster, so you will have your nodes loaded in more or less the same way. So you will not have the third problem, and you follow the third and last rule of a good partition. Avoid not only big partition, but avoid hot partition. What does that mean? Primary key user ID. In this case, we are going to have as much partitions as users we have, and they are evenly distributed across the cluster servers. And that's perfectly fine. I want to focus on the third example, though, with country and user ID. So list of our users per country. Take a look. Imagine you work in e-commerce and you sell some things and you're operating in Europe. Europe has a lot of countries, some of them are not so big size, and it all goes good, and you partition your customers on country basis. So, does it work? Yes, it works. Then you go to the country like India or China, and there are much more people, and you are still using the same data model. And congratulations, you were very successful. Everyone wants to buy for you. The whole China buys your goods. That's cool. My congratulations. But here comes the problem. You now therefore have one overloaded partition with operations being executed all the time, while other partitions are underloaded. What that it makes? Imagine you have 10 servers in your cluster and replication factor 3. Therefore, your Chinese partition will be stored on 3 servers. And they are extremely busy. Again, the whole China is buying something from you. Operations happening all the time. 3 servers are busy, 7 are idling. You know what Cassandra scales elastically and linearly. So you just, oh, okay, now I have money. I will buy 10 more servers. And you buy 10 more servers, you run them, join cluster. Now your cluster consists of 20 servers. What happens? Basically nothing. You still have replication factor 3. You still have 3 servers responsible for your hot partition. 3 servers are busy, 17 are idling. You can throw 100 more or 1,000 more. It will not help. With a bad data model, you can ruin everything. So, think of that. Highest Cassandra performance is a shared responsibility. Shared responsibility means what Cassandra gives you away, but if you don't follow this way, you will not have this performance because your data model is wrong. So, avoid hot partition and design the partition way will be loaded more or less evenly. It's fine to have some discrepancies, but anyway, avoid some overloaded partitions. this example on the video and comments, you may say, okay, some videos are being commented all the time and some videos are not being commented. And what's my answer to that? Is that a problem? Not really. Why it's not a problem? Because, well, technically you are right. Some videos are being commented much more often than others. And the answer is yes, but there are a lot of those videos. And video ID is unique, and they are distributed over the cluster of our nodes. So if I have some servers and if I have some videos, they have every server loaded evenly. And then if I add more servers, I have 10 servers, I add 10 more, I multiply power of my cluster by 2, because Cassandra scales linearly. What happens then? The partitions will be distributed to the new cluster members, and all the load on all the servers will decrease, but it will not happen if I have one overloaded partition. So that's what's very important to understand. So, last part, Cassandra data modeling methodology, finally. So, there is a great gentleman, call it Artem Chebatko, which developed data modeling methodology, Dr. Artem Chebatko. We are very happy and proud to have him as our colleague. He works for DataStax, and that's actually great news for us. So, he developed a data modeling methodology and also notation to record the Cassandra data model to be able to communicate with others on how do you see this data model has to be done. And the idea of this data modeling methodology is very simple. So what the data modeling in general is: collection and analysis of the data requirements, identification of participating entities and relationships, identification of data access patterns, particular way of organizing data, specification and designing of a database schema, and finally optimization of and indexing techniques. So basically that is the main slide of the wall 2 hours workshop. So if you want to make a screenshot, that's a very good time to make screenshot or a photo of your screen, because that is the most important slide of the whole workshop. Cassandra data modeling methodology: 4 objectives, 4 models, 2 transitions. First, on the left side, we have the things we start with. We need to understand the data. We analyze our data and describe it using entity relationship diagrams. I will show you in a moment. And as a result, we create conceptual data model. So entity, their properties and relations. When we have to understand access patterns or workflows, we describe them with application workflow diagram. And we create as a result application workflow model. Having conceptual data model and application workflow model, we map them together, and applying the query first, query is the queen approach, we get logical data model, describe it in the Chebatko diagram. Then finally, we optimize this logical data model, optimize and implement some optimizations, you will see, and we get physical data model. As a result, physical layer Chebatko diagram and CQL, Cassandra Query Language Schema definitions. So, that's again all the design process, step by step. Entities and relationships, and application workflow queries, mapping conceptual to logical, applying physical optimizations, getting physical data model, and schema definition language SQL. Let's do it step by step. And to do it, we use a sample data of video and comments. And by the way, thank you so much for the warm comment you give to our videos. That's all. We are always very happy. We are sharing them in internal Slack with others. So we will share some love all
Yes.
these. Thanks, guys, for this great video. All the data stacks gets those, and we are very, very thankful for you to keeping those very warm
This
comments.
is our pride.
Yeah, indeed. So, video has comments. And you may say, Alex, why do you want to develop a data model for comments? It's maybe too simple. I mean, comment, you just told us 10 minutes ago, comment ID, video ID, user ID, username, text, timestamp. Do we really need, is it a really good sample date to work with? Wait a moment, stay with me and you will see. So, first step, understanding your data. We have to create conceptual data model based on the data, its properties and relations. Cassandra is non-relational database, but we still need to understand the relations. So, idea is very simple. User comments on video. Video is being commented on by user. User has properties, ID, email, name, age, and so on, some user data. And video has ID, title, description, and some other data. When comment has some properties as well, timestamp and comment, and it's a many-to-many relation. One user can write many comments to a video. One video can have many comments from a user, but every comment has one and only one author, and any comment is being commented to one and only one video. So you can't write a single comment to multiple videos. Okay, so that's our conceptual data model. User, comments, video. And then we think of the application workflow. And here comes a story of the workflows. The story of the workflow for the comments is interesting. We use it to see comments per video. You open a video and you see the comments for it. And that's a use case 2 we discuss here. User opens a video page and we have to retrieve comments for that. As a result, our workflow is find comments related to target video using its identifier, most recent first. User selected video from a list, so we have video ID, and we need to load comments using this video ID, most recent first. This use case is simple and obvious, but there is a second use case you have to consider. User opens a profile, wants to see his or her comments, to see likes, dislikes, answers, and so on and so forth, all together in a single place. And there is one more use case. As a moderator, you know user stories from the idea from the software development, how to design requirements, user stories. As a moderator, to understand if user is a spammer or not, if he has to get banned or not, I open a comments page of this user to read through his latest comments and decide if I want to suspend this user. Basically, idea is the same and workflow is different, but the outcome will be the same. Find comments related to target user using its identifier gets most recent first. And now you see we have two different workflows, or three, but two of them are matching. So we have two different workflows to react on this situation. And it brings us to the next point. Now, mapping. We unite together conceptual data model and application workflows, bring them together and think of the queries we are going to execute. Find comments posted for a user with a known ID, most recent first. Find comments for a video with a known ID, most recent first. And we convert them into query, describing them in Cassandra query language. Select all from comments by user, the user ID equals something. Select all from comments by video, the video ID equals something. And at this point we start to think When we are loading data for a user, comments by user, we know only user ID. When we load data by video, we know only video ID. Now think, can we have a single table to retrieve this data? If we want to stay efficient, if we want our data to be loaded fast, please answer on the YouTube chat. Can we use a single table to fulfill those queries?
Well, looking at the screen, seems like it will be challenging, right?
Yeah, well. Cedric, don't give hints. We have some dozens of people and I want them work. I want them to be tired after this workshop. You know, it's like a workout in a training room. You need to be some tired to get some skills. So, Anil Kumar says, yes, we can use single table. Pavan says partition with video ID, user ID. If we could use two different indexes with the right combinations of primary and cluster key. Okay, I see your answer. And I don't have the right answer here. Can we do this job having a single table? Yes, we can. Should we? No, we shouldn't. Why? Take a look. If you build table like say in this comment, partition with video ID, user ID, then you execute a statement. You have to always specify the partition ID, full partition ID. If your user and video ID are both the parts of a partition key, therefore you need to specify video ID and user ID as a part of your statement. And you don't know it. You know or video ID or user ID, but not both. And take a look how it works. Idea is very simple. You want to order food. Order food by whatever delivery service you prefer to use. What's the most famous pizza delivery in the world? Like Domino's or
Yeah,
Papa John?
In the world, I don't know.
I don't know.
Domino's pretty famous.
Let's say Domino's. When you order pizza by Domino's or whatever service you prefer, are you going to give them the full address of yours or just the street? You tend to give the full number, the full address. Why? Because you want delivery person to go directly to your door and knock to your door, not your neighbors, or no, not the door next building or next street. You give the full address. And it's the same goes for Cassandra. If you do not specify full partition key, it's like you aren't giving the exact number, you're just giving the street, but not house number, not your name. And then the delivery person will have to knock every door on the street and ask, have you ordered pizza, sir? Have you ordered pizza, ma'am? And as long as
everybody will say yes.
as long as you live on a small town, on a small street, it even may work, but it's definitely suboptimal. And that's the idea. Take a look. There is one unobvious thing which understanding of which is really important to know how Cassandra works. Cassandra drivers you use in your applications are extremely smart. DataStax and Cassandra community as well did a great job developing them. Basically, when your application starts and your driver, let's say you are using Java application. I mean, Cedric is a Java guru, so in respect to Cedric, let's use Java driver today. Mental him. Yeah, let's say you develop Java application and your Java driver starts in the beginning, connects to the Cassandra cluster. What does it do? It's not lazy and it's very smart. It loads information about the cluster and schema distribution and data distribution, partition tokens over the whole cluster, Then you ask to select data by user ID for comments by user, and you give user ID or whatever partition you give, it doesn't matter. It will calculate the partition ID at the site of the driver. It will apply to the information, it will ask for the information it stores of which server is responsible, which replica server is responsible for your data, get the IP and go directly to your server, not asking every server on your cluster. There may be thousands of servers, but it goes directly to server responsible for your data. But how it will work if you don't give all the fields of a partition key? It cannot work. If you don't give the keys for a partition, it has no way to go to a partition, to a particular server responsible for this partition. And then, like this poor delivery boy, it has to knock every door on your street. And on big clusters, it will take ages. It's called full cluster scan, scanning the full cluster for your data. And that's obviously very, very, very bad idea. So if you want to be quick, you need to have two tables. Yes, you can force Cassandra to retrieve data from a single table. You can force Cassandra to do full cluster scan. But if you want to be quick, no way, no way. So in short answer, you cannot use single table here. You need to have two tables. That's what I say, up to table per query. And in this case, we have three user workflows for moderator, for user, and for video, and two tables for that. Comments by user with user ID as a partition key.
Oh, we lose.
Yeah? Cedric? Cedric?
I'm back.
Oh, okay.
Just have a micro something. Yeah, everything just froze for a sec. Sorry for that.
Oh, no worries, no worries. It's good you are with us. So, you have user ID as a partition key and creation date and comment ID as clustering columns. We need creation date to establish sorting order, and we need comment ID to ensure uniqueness. And video ID and comment are data fields. And comments by video. Video ID is a partition key, and creation date and comment ID is clustering columns. Basically, tables are identical, but you just need to have video ID or user ID as a partition key at this point. Good. So, does denormalization apply in this scenario of two tables? Yes, denormalization applies because you want to show also author name, and author name has to be here. We are just simplifying this table a little bit, but yes, you will need author name here, not only comment. So author name will be here, author name will be here, and author name will be in a users table. So you see that's the denormalization. Cool. So looks like that must be clear. Anil Kumar, with this approach, I have to insert same data in the two tables. Yes, exactly. That's what we told you some slides ago about the denormalization. With denormalization,
even if it's exactly the same data, same column, same values.
Yes, denormalization means multiple writes. Yes, exactly. That's the downside of a denormalization. That's exactly what I said some minutes ago. Would it be efficient if we put the text of a comment with a creation date in a separate table and link by comment ID? No, it won't, because in this case you need to basically load information from two different places, so you will have to execute two select statements. It makes no big sense, because why do two select statements if you can do one select statement? Good. So let's move on. When we have logical data model and we have to proceed and switch to physical data model, what is it about? We apply some optimizations to have our tables smaller. And logical to physical, we are applying in this case only one optimization. we had user ID, creation date, and comment ID as clustering columns and user ID as a partition key. And now we have only one comment ID, which is a type of time UUID. What is that? It's a great data type by Cassandra. It's a universally unique identifier with data, with timestamp integrated. And that's actually really great. So you can have all the data you need, both as an unique ID, but also as a timestamp. And it's sortable by time, and you can extract time from it. So that's a great type. I merge together timestamp and ID, and I bring them together. That's really cool. Obviously, same applies to comments by video, where comment ID also will be type time UUID. So my table's now a little bit smaller, and I still can sort by time, and I still ensure uniqueness. So I merge creation date and comment ID together into the time UUID comment ID. Pretty cool. So, and finally, last step, we get the schema definition based on the physical tables designed in the described in Chibatko notation. Create table, if not exist, comments by user. The user ID going to be UUID type, universal unique ID. Comment ID is going to be time UUID type, time universal unique ID. Video ID, we need to link video, will be UUID. Comment as text, primary key by user ID and comment ID, with clustering order by comment ID descending, because I want to see what? Most recent first. The same idea goes to comments by video, with the only change what video ID will be partition key. So we did that. Now, to help you with the homework, as a part of your homework will be order management example. And I want you to do it on your own with a practice, but I will help you a little bit with a design. Okay, Cedric, are there any questions maybe?
No, I try to understand design ideas for having everything in a single table keep coming, but I have a hard time to track those. But no question except from these designs.
Yeah, good. So yes, there is basically no way to have anything better than tables if you want to be performant. So
yeah, they try to do, you know, like everything in a single table, item ID, item value, item ID would be video, but then you will have all the videos in all the command for all the video inside the same partition.
Yeah. So you are trying to use denormalization, but not paying the costs. You know what? It's like there is always a price to pay, and to have and to be able to work with petabytes of data and dispatch answers within single-digit milliseconds, there is a price to pay, and this price is the denormalizations with the denormalization downsides, which includes multiple writes. And yes, your application has to use multiple writes. There is a trick to help you with multiple writes called batch. We will discuss it briefly in a couple of moments. But first, let's talk about order management, the work you will do on your own with us supporting you and answering your questions on Discord. So, order management. Everyone understands the basic idea of order management. I can order something by Amazon, for example. Item is ordered, item is shipped, item is delivered. And we have to track orders and that status. And when we start to think about the data, it may look a bit scary at first. So, but actually it's much easier when it looks like. So that's entity relationship diagram for my conceptual data model. And the idea is very simple. I have user, with ID, email, and name. That's my user. User has three relations. First one, user has address. Second, user has payment methods. And user has shopping cart. Very simple. So with payment method, it's all easy, summary and details, some payment specific things like PayPal, for example, or whatever, MasterCard, I don't care. When address has also so summary and details, and we may have up to 2 addresses per order, which is shipping and billing addresses. And shopping cart has ID, name of the shopping cart, and some subtotal of the overall price of this current shopping cart. Shopping cart contain items. And we can check out shopping cart with some delivery options, executing an order. And this we speak about order first of all. And order has order status history, history of the changes. So basically that's the overall schema, overall entity relationship diagram for the single order. User, address, payment method, shopping cart, item, order, order status. That looks a little bit too much, but don't worry. You will see in the homework we prepared everything for you. So you don't have to create 1000 of the tables for that on your own. You will see how it's done in Katakoda. Then we have to talk about application workflow, and the thing of the workflow we are going to do with our order management. And we discuss 4 queries for the select, find all orders placed by a user within some time range. We want to show user his recent orders. We need to find all information about the order. So first one, show orders placed by user. Second, display information about an order. So user clicks on the order. When we need to do some, to show order status history, what changes were done, shipped, delivered, paid, and so on. We show orders placed by user containing a specific item, and we have one update to add a button to be able to cancel orders. Very easy. And when that's the steps you will do already on your own without me, you start to describe the tables, how they would look like, physical models of the tables, and you apply them. I will show you in a second. Actually, I believe I have it somewhere here. Yeah. So Katakoda, I will send you a link. Where is the link, by the way? Yes, that's the link for your homework. I will send it again. Don't worry, I will send it again. But the idea of this, let me show you. Please don't do it right now. Wait a second, stay with me. That's the category. Oh, okay, my environment has expired, of course.
Timeout.
Timeout, yeah, I created it for too long ago. So I have to reload page, start scenario. So everything is prepared for me. Cassandra is running on Katakoda for me. Training node is sponsored by DataStax. So DataStax helps you to get the training node for that, and you don't have to install anything on your laptop. And actually that's only the practical part, but I want you to walk through again the theoretical part as well. datastax.com/learn data modeling by example. So we have a whole library of data modeling by example describing different examples: sensor, IoT, messaging, time series data model, investment portfolio, shopping cart, and now we specifically work on the order management data. So I will simply get here, and this is the link actually you should use. I'm sorry, first link was to practical part, but you have to walk through theoretical part as well. So order management data, and here it's all explained about the application workflow and entity relationship diagram and logical data model and physical. And in the end, Oh, that's Artyom, by the way, a developer of data modeling framework. So you just push the button start scenario and you get your training infrastructure right in your browser. So that's how it works. I send the link. So yeah, link is directly above your comment. Cool. And then you can, as soon as Cassandra is running, it must be running already here, I guess. You can just type commands right here. So I can describe case spaces. Boom. And I have, I can say like, I don't know, use case space system. Boom. You are using key space system. Describe tables. Boom. My tables, and so on. Or the second part, you can just push the button on the left, this field, and the command will be executed automatically. Now I use order management data. Use order management data. It must be pretty empty. Oops. Describe tables. Oops. Come on. Tables. Okay, no tables. And when I click to continue and start to create tables, you see they are prepared. So you have to only walk through and read thoroughly what we are doing here. And you execute them when we can load some data and so on. So boom, we have data loaded and we can execute our statements already. And you see what we have different orders and do next steps. And finally, in the end, there is the part you have to do on your own. You have to design queries to load data. And if it doesn't work to you, if you cannot load data, you are free to use the solution. Just click the solution button and you will get the solution. But I really recommend you to try to do it on your own. You do it not to learn how to click buttons, click, 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 continue, done. You can, but I believe you already know how to click buttons. You do it to learn how to use Cassandra to be a better engineer, to earn better money, and so on and so forth. And to do that, you have to manually type things like select, all, from, orders by user, and so on. Okay, so push those buttons. There is a time to be lazy and time not to be lazy. That's time not to be lazy. Cool. So that's what we are going to do. And oops, where is my button? Good. One last word before we go to quiz about batch. Batch helps you to run multiple commands into a single into multiple tables within a single statement. Notice it's not a relational batch, it's not a relational transaction. There is no rollback button. You cannot make like batch apply, batch rollback. But it works differently. Batch is persistent. As soon as you submit batch, it will execute all the statements. If it fails, it will repeat them. And it's persistent. So even if your node fails, batch still will be executed and batch will be delivered to other nodes. So batch is a thing which is highly reliable, and batch is used to deliver updates, deliver mutations to multiple tables at once. And that's a very cool mechanism. That's a mechanism you recommend to use to deliver your update statements into the multiple tables. Batch is a separate story. It's not a part of this workshop. We expect you to have some knowledge of this kind of thing already. If you want to write to multiple tables, you can use our scenario for batch on Katacoda. There are dozens of scenarios, so our team did a great work actually preparing training scenarios on Katacoda. Palvinder asks, please share some idea of money a Cassandra engineer earns. Very good question, really makes sense. So numbers will vary from country to country and from company to company, but let's take a look at this. Cassandra is not a simple tool. Cassandra requires some knowledge and some skills. And you usually use Cassandra with close to big data or big data. So companies are using Cassandra definitely have money, because if you have a lot of data, you usually have a lot of clients in most of the cases. Biggest companies using Cassandra, so Instagram, Netflix, Apple, Huawei, Reddit, Twitter, and so on and so forth. So basically, I believe 3/4 of S&P 100 biggest and most profitable companies in the United States, for example, are using Cassandra. Most of them. Basically,
Yeah,
you're using Cassandra all the time as a client.
Yes, so I mean, we did a survey. It was about 20% more, but as Alex stated, it's just based on where you are based and the situation there. But you know, it's plus 20%. I will see if I can find the survey during the game.
Oh, Giri Prasad, I have a good news for you. I'm interested in Cassandra administration and Cassandra. Will there be the workshops on those topics? Yes, absolutely. So for Cassandra, we already have workshops. So if you can't wait, you can watch the recording. If you will need a training note with Kubernetes and Cassandra, you can ping me on LinkedIn. I will create one for you. And for the Cassandra administration, we have something better than just the workshop.
Workshop, we have real courses, yes.
So we have the academy.datastacks.com with the courses. You see, Cassandra operations is a big topic. I cannot explain you Cassandra operations within 2 hours. I would love to, but it's not so easy. So academy.datastacks.com, it's free, and you can go, for example, to the admin learning path. There are free courses.
We also have a playlist on YouTube. I shared the link for DS210.
Yes, but in general, I recommend to stick to Academy. Yes, we have videos
to
on
get
YouTube.
the exercises and the tracking and get the badge. And if you finish DS210, you can ask for a voucher and the certification through.
Yep, exactly. So Academy works a little bit too slow to me, but hope now I can get it. Yes, and so DataStax Academy Apache Cassandra Administrator path, finally. Could you please show me learning path? Yes. So it includes 3 courses: introduction to Apache Cassandra, DataStax, well, ignore this, just foundations of Apache Cassandra, operations of Apache Cassandra. Please ignore this DataStax Enterprise 6 part. It's all about open source Apache Cassandra, okay? We have to rename them, for real, we have to rename them. It's misleading. So it's just foundations of Apache Cassandra, operations with Apache Cassandra. Cool. So that's what we have for administration task. And oops, wrong button.
Yeah, and you know, I shared the link as well on datastacks.com/dev. We created a courses on Cassandra, and I shared the link.
Good. So quiz time. We are on the end of an hour, actually. Oh,
yeah. Let's play the game. Let's win some swag.
Let's win some swag. Get back to main team. Set the thumbs up. I know you are
ready. I will play with you today. Okay. I want to play today.
Yeah, I understand. It's a lot of fun.
Yeah. Wait for me. I want to win some swag as well. You know. Would you beat me? Come on. Everybody go there.
Hey, don't let Cedric grab all the prizes. Go beat him. Don't let him grab the prizes.
Do you want that t-shirt?
Cool.
Everybody's so excited now.
Yeah. Very well. So, more and more people joining. I see almost 50 people watching us on YouTube. That means what you are going to have a rough competition today. So, some dozens of people, only 3 winners. But still, I want you to participate and do your best. At least, you see, you already won. You already earned a lot of knowledge. That's what prize is. I mean, okay, t-shirt, you can grab your t-shirt on the next event, or you can grab your t-shirt by participating in more and more workshops and earning badges. That's cool. But what really matters is knowledge. So enter the code 34919972, or just scan the QR code next to Cedric. And let's go. I'm about to start it. Oh. Quiz time.
Oh, quiz is not open. Yeah, it's
Yeah, I'm about to start.
Ah.
So, answer fast to get more points. A key space is organized into rows and columns, contains tables and sets replication, is the base unit of access, is a place to store extra house keys. It's the first question, so we give you time to think.
And you know, I took a lot of time for this one. You know, need to read carefully the answer, just not to get wrong. So I may not be in the top 10. Maybe I'm wrong. So
we will see soon. So, correct answer. Key space contains tables. That's the correct answer. Key space is not the base unit of access. It's a partition. And key space is not organized into rows and columns. It contains tables, and tables organized into rows and columns. So let's see the leaderboard, how the leaderboard looks after the first one. Agent X9 is on the first place, Spanda is on the second, and Wolfmeister is on the third. That's cool. And Millie is actually third place is splitted between Wolfmeister and Millie, and Dragonite is just few points below on the fifth place. But that was the first question, ladies and gentlemen. So focus, we still have questions for you. Well then, question number 2. Answer fast to get more points. Things will get harder now. What is a partition key? An optional column to allow group by. A column to define partitions required. A required column to set sorting order. The key to all the doors. Time is up, and the correct answer is a column to define partitions. Not to set sorting order, but to set partitions. So, what are the changes? Oh, I see Cedric. You wasn't you still not in top 3. How could you? But Agent X9 is doing very well.
Sorry, I need to read the question because I don't know the question. Okay.
Good.
And I don't want to miss, like the presenter, just misclick or provide the wrong answer.
Good. So Agent X9, 2 fastest answers in a row. That's a nice result. Spanda is on the second, and Millie got to the top 3 with Sam on the 4th place. Good. Let's take a look what happens next, and we still have some questions. Question number 3. Answer fast to get more points. Table can have many rows per partition. True, false, requires special configuration in the Cassandra YAML. It's illegal. That must be illegal. Cedric, what do you think?
Yes, you can get arrested for that.
Yeah. So, correct answer is true. Table can indeed have many rows per partition. It's absolutely legal. You don't need a lawyer to have many rows per partition. But it's fine to have 1 row per partition as well.
I mean, it's a group by, so.
Yeah. Good. So, who was the fastest one? Millie was the fastest, but there are no changes in the top 3 still. Agent, Spanda, and Millie, with Cedric on the 5th place. Okay, and then there are some changes on the downs. In the bottom of the leaderboard, top 10. Okay, so let's see. Question 4 of 8. And I'm going to ask you, and you have to answer fast to get more points. In Cassandra tables, which are required? This one is tricky. Don't make a mistake. Data columns, clustering columns, partition keys. What are required in Cassandra tables? We give you some time because you may need to think on that. Okay, time is up. And the answer is partition keys. You are right. Partition keys are required, and clustering columns are optional, and data columns are optional as well. Partition keys are required. So, what are the changes on the leaderboard? Will any one of the leaders make a mistake? I want to see. Millie is the fastest, jumping directly to the first place with 3,861 points. Great job, Millie. Spanda holds the second place and Agent falls to the third, which is still enough because our prizes for the first and second places and third places are the same. Okay, so Cedric, looks like you can't get to top 3.
No, I can't. Nothing's moved.
Cool. Question number 5. Answer fast to get more points. Inequality predicates are allowed on which kind of columns you can use inequalities? All table columns, partition key columns, clustering key columns, or no inequalities are allowed. That may require some experience, but most of you have answered it correctly. Clustering key columns, that's correct. Clustering key columns allow inequalities, and partition key columns don't, because you have to specify your partition explicitly. So, are there any changes in the top 3? Are there any changes in this? Millie, it was a mistake. Oh my god! I'm so sorry. Yes, and boom to the 9th place from the first. That must feel bad. Indeed. Spanda, Agent X9 and Sam got to the 3rd place thanks to mistake of Millie, and Cedric the presenter is on the 4th. With Shubham
I'm so
very,
serious,
very
you know.
close.
I'm on my swag, so close.
Cool. So, question 6. And we are going to ask you, so answer fast to get more points. In the data modeling methodology, we start modeling with physical data model, with logical data model, with conceptual data model and application workflow, with copy-paste from Stack Overflow. Famous Stack Overflow driven development, I do it all the time. Okay, correct answer is conceptual data model and application workflow. Logical data model is the consequence of mapping conceptual to application workflow. And physical data model comes last. And no one has answered with copy-paste from Stack Overflow. Liars, I know you copy-paste all the time. Okay, so Puggy was the fastest, getting to the 8th place, and Millie keeps doing well, like racing. But will the time be enough to get back to the top 3? I'm not sure. Oh, Cedric got to top 3. Yeah, congrats. So
size
Sam,
M for the t-shirt, size M.
3 points difference from Sam to Cedric. Sam, keep fighting, take him down. Like, I'm all for you, and Spanda and Agent on the 1st and 2nd place. Cool. So that's the question number 7, and we are going to close soon. Answer fast to get more points. Primary key defines row uniqueness. False or correct? Primary key is deprecated. I believe it's deprecated, should have been deprecated for years already. Why didn't we drop it? We should drop primary keys. Chat is so quiet, no questions.
Of course, you need to be so focused.
Correct answer is yes, primary key indeed defines row uniqueness. That its main job.
Correct answer is correct.
Yeah, correct. Very easy. So, what are the changes? Who is the fastest? Agent X9 is the fastest, And there are no changes this time, so the top 10 looks exactly like it was after the previous question. And now finally, that's the end of the quiz and the last question I am to ask. So answer fast to get more points. How does Cassandra perform joins? How does Cassandra perform joins? Cassandra joins require a join table, just like SQL joins. Cassandra does not support joins. Cassandra only joins clubs. There is a question about primary key in the chat. I cannot say I understand the question, sorry. We can discuss it later on Discord. So, correct answer, Cassandra does not support joins. And answer, Cassandra joins require a join table is wrong because, well, there is no thing like a Cassandra join. You can retrieve some information into selects and then join on the application layer, but it has no relation to Cassandra. So that's not exactly the join at the database level. Cassandra does not support joins. And that was the final question. There are no mistakes in the leader list. And all the people answered very quickly with Agent X9 was the fastest. But we want to congratulate winners. Cedric is obviously cannot participate in the prizes. As you are, I forget to tell you, you are a company employee, you don't get the swag.
Oh, jeez.
I will tell you next time, I'm sorry.
So Sam would get the prize then.
Yeah, so Sam will get the prize.
All the winners.
Spanda, Agent X9, and Sam. Please contact Jack Pryor. Oh, Jack is here already. Thank you, Jack. Congratulations to Spanda, Agent X9, and Sam. Please contact Jack Pryor at jack.pryor@datastarks.com. Please make a screenshot or a photo of your Menti screen with your prize place.
And if you already won this contest before, please, let your seats to the others because we would like everybody to win. And we don't ship twice to the same people.
Okay, Aki. I see Peptide. Now I understand the question. Can you insert two records with the same key without an error? Answer is yes, you can. Default behavior will be second record overwrites first one. That's the problem of John Smith.
The second
record
won't get any error. No integrity constraint, but it will upset.
Yep. If you want to avoid this behavior, you have to use lightweight transaction. There is a thing called if condition, if, and you can use conditions in your statements. So you can tell insert John Smith if not exist. In this case, Cassandra will apply read before write, and it will not be applied if this customer already exists. But the problem is that comes with a price. So you pay with a performance on that. So if you want to be on the high performance side, you better avoid lightweight transactions when it's possible. There are some good use cases for the lightweight transactions. But not use them on every case. Great. So thank you for the warm feedback. I'm seeing you are mostly enjoying the workshop, which is great to know. Yeah, I'm happy to see like 8.8. That's a very warm result. Great. And final thing I want to ask is the open question. Do you like it? What would you suggest? Any feedback, any content maybe you think we have to produce? And so on. So please answer what you want to see in the future and so on and so forth. I will keep this page open so you can type your answers. Nice only. Thank you. So you can keep it like that and answer in the background. Good job. All workshops are great. Yeah, we do a lot of workshops. Thank for speaker, especially Cedric. Cedric, hey Cedric. There is a
Why
special...
Cedric was just quiet all the time. Is it a meme?
Cedric was answering questions in the chat all the time. I'm only hearing all the time. Explain more on table query. If you didn't get something, please catch on Discord or at the community.datastacks.com if you prefer chat or forum. Good. Oh, this one is a good one. Get back. Maybe a workshop on how to develop I clicked on you. Oh yeah, here we go. Maybe a workshop on how to develop program using any driver, like connecting the Python driver and retrieving manipulating data.
Yeah, we do have those.
We have it already.
Yeah, we do have multiple sessions recording on the channel. So again, if you like the interactivity, consider to subscribe. In this channel, everything is recorded, and we do have a workshop on how to use the Python driver, how to use Node driver, how to use Java driver, how to use Spring Data, Flask, everything that you would dream of. And when it comes to Python, I think the next month we do have something scheduled for you.
Yeah, definitely. Cool. So, okay, I will keep this window open so you can write your comments after the workshop. And to finalize, what's next? So, homework. I've sent you a link. We have to do order. And if you have time, it would be really great for you to do Cassandra data modeling, scenario, and sensor data modeling. Sensor is different and very interesting because it's about Internet of Things. It really opens your mind in this field. So I do recommend to take a look at this one. I'm to send a link. So there is a collection of all of our scenarios. And I send the link to you now. Oops. Yeah, like that. I recommend you to do order data management and sensor data modeling for this. And now, how do you how do you submit your homework to get your badges? It's not yet automated. Sorry. So the easiest way for you to submit the homework is to find me on LinkedIn and send me the screenshots of your work is done. In the end of the scenario you will have this nice scenario is done picture. You will see it when you complete. So just send me in a private message a screenshot of your scenario completed, and I will include you to the list and you will get your badge.
Cool.
So yeah, simple as that. And the link is here, so I'm to send you the link.
Oh, Shemlek Plus, I will send my LinkedIn as well then. Okay. Public profile.
Boom. So, want to learn more? We have datastacks.com/dev, a lot of content here, and we have, as you've seen, academy.datastacks.com. Join community at community.datastacks.com. That's kind of a Stack Overflow dedicated for Cassandra related things. And especially join our Discord, where we will be really happy. And by the way, yeah, I see Cedric pasted a link to his LinkedIn in the YouTube chat. We spent more than 2 hours together. So please add us as friends and LinkedIns. We are almost colleagues now, and we work on the single topic. So yes, jump in then in Discord and jump into our LinkedIn.
9982. Do you believe that? Come on. All right.
Good.
Thank you very much, everybody. It was a pleasure.
Yeah, it was a pleasure. You see the Cedric? Under the Cedric, you see like and subscribe buttons. That's a good time to push them right now. And thank you so much for being with us. We are very happy to see you joining the workshop. What's our next workshop, by the way?
Okay, so next week it will. Oh, this Saturday, if you speak Russian, we do a Cassandra day in Russia, explaining everything on Cassandra in Russian. Then on next Wednesday, we will do intro to NoSQL database, where I will explain you what is the difference between graph database, document DB, key value, and use all of them. In 2 weeks, it will be how to move from a relational database to NoSQL database. So kind of a follow-up.
Mm-hmm.
And moving forward, we'll go back to coding and probably show to you a little bit of Node.js, Java, and Python in the 3 other weeks.
Yep. And we have more in the future, so jump in. We travel through a very interesting road, and we are happy to have you aboard. Thank you so much. And I think we are done for today. Hey, Cedric, thank you.
Thank you, Alex. My pleasure, as always.
Yeah. So enjoy some music in the end, and we are done for today. Thank you for coming, and see you next time.
See you next time. Bye.
I found someone new now. I have more room, no more formats to change.